Okay, so we have seen kind of the output, the experimental output. Now we have kind of, so these are the readings. Now we'll collect this IC to the proper place. So this is just for sake we did. Okay, so we'll collect IC at that place. Okay, so we have kind of connected back the IC. So, okay, so this is the actual circuit and collector of the PNP is connected before kind of the speaker, and now we have measured IB, VB, current across the capacitor, IE and IC of the PNP, and voltage across the speaker. Okay, so voltage across the speaker also we have measured. Voltage across the speaker. Okay, now we have all the graphs ready. So this is IE, that is NPN transistor, and these are the readings we found. And from the graph we can see like the IE. So this is when transistor comes in kind of conduction. Okay, so transition current comes in conduction while at the same time capacitor is discharging. So we can see I is falling. It came to conduction, I mean active region, the transistors, but the current, the emitter current is falling continuously, and capacitor is discharging to a level that it is switched off. And this period there is no current, okay, zero current, and then suddenly, so this period capacitor is charging, and this period capacitor is discharging. So while capacitor is charging, transistor circuit is disconnected, means is zero, and then capacitor suddenly charged to a level that emitter transistor become active. So this is now same we have PNP IC. So we can see that current is 2000 around 2 milliampere. It reaches 2 milliampere, the IE. Now if we talk about the IC of the PNP, same story. When transistor become active, then it also become active, and the capacitor is charging, so IE is decreasing. So this is also decreasing, but it reaches around I believe 120 milliampere, the IC. Because of that, a speaker is working, that we have seen. Okay, now capacitor is discharging. So while transistor circuit is active, so capacitor is discharging the way we demonstrated. So first of all, capacitor is charging through this path. From the VCC it is charging, and when it is charging, it comes to a level where VB is kind of a 0.6, and this transistor becomes active. Okay, and when it becomes active, at that time this junction, the diode junction, the resistance is very low, and capacitor charge discharging. So it is a kind of a dilemma that circuit is becoming active, but at the same time capacitor is discharging through the base emitter diode junction. So current is decreasing, so transistor become active, but at the parallel a capacitor is discharging. If capacitor is discharging at one level, capacitor is discharged and suddenly it falls, means it can be seen. Okay, probably we will see in the VB. So this is how the story of IC. Now capacitor, so first let's see the VB, the most interesting thing. So when capacitor is charging, it comes to a level when VB is 4.4 somewhere, suddenly it comes to 6. This is the internal energy of the transistor. So this is the inertia or internal energy of the transistor. This is, we can see everywhere. This is the situation. Can we see this? So if voltage at the base of the emitter, it reaches to a level, then suddenly it picks up automatically. So from 4.4 to active, it picks up automatically. It remains active even though the capacitor is discharging. When it discharges to a level where transistor cannot hold its active condition, then suddenly it drops. Now capacitor is charging, so VB is again growing, and capacitor is charged to a level that it is 4.44. Again it picks up immediately. This is not capacitor phenomenon. This is a transistor phenomenon. If transistor base is coming to a level, it is picking up. Okay, so this portion is capacitor discharging and transistor is inactive, and this portion capacitor is kind of discharging and transistor circuit is active. Now we have seen IC. Now current across the capacitor. So capacitor current it drops. So from here we can see capacitor current. So capacitor is when there is a negative current in the capacitor, minus 40, then it goes up to minus 90, then comes up to minus 40 and then 0. Okay. So negative current shows that capacitor is in discharging mode. So capacitor is capacitor is discharging, and from here it is charging. Okay, so we can say from here to here, while it's the discharging, the current is minus. Minus means capacitor has two type of current. One current is coming from the voltage source, and current is in this direction from top to bottom, and when capacitor discharging from bottom to top, the current, so it shows as negative. Okay, so capacitor is when it is charging, it is around 11 microampere, comes to 10, then comes to 9 microampere, and then suddenly capacitor, when transistor become active, suddenly capacitor starts discharging immediately. So this is the better curve. I think we should not demonstrate this. This is the beginning one. So then capacitor suddenly it reaches to minus 90 or something microfarad. Okay. Now capacitor is negative. Means capacitor is discharging. Capacitor is discharging to a level that transistor become active again. So transistor become dead again. So if we see the capacitor phenomenon, then capacitor is charging, okay, and right side, this area is completely dead when capacitor is charging. So while capacitor is charging, I can say that this area is dead. This is a very big thing. This area is dead. When capacitor is charging from this direction, the transistor circuit, so there is no current in IB. and it is dead. So it is taking complete charge from the voltage source. Okay. When VB is when transistor is coming in active, okay, then now transistor is active. Then capacitor is finding this path, unfortunately, to drain. Okay. Now capacitor is finding this charge path to drain, and it is draining to sink. Okay. So this path when taking, then at that time it is showing as negative. Okay. So capacitor, while capacitor is discharging, transistor circuit is active, and when transistor is active, okay, when we see VB, it holds at that position. Even though capacitor is discharging heavily, but it holds till it is active, and suddenly it is inactive. And this is what we are seeing in the capacitor also. So capacitor is okay. So capacitor is in negative side, so it is discharging. Okay. Now it comes to a level where capacitor is discharged and transistor becomes switched off. When transistor becomes switched off, then capacitor starts charging again. It comes to this level and it start charging. So when capacitor is charging, at that time, at the beginning, the current will be high. Then slowly current will go down as it is charging. Okay. So this is the capacitor. Now if we see the IB, the current that is flowing inside the transistor. Okay. So IB here has when transistor is inactive. Now when transistor become active, then IB comes to 120 microfarad, I believe, and then IB is decreasing. While capacitor is discharging, IB is decreasing, and suddenly the transistor becomes switched off and IB also becomes 0. So this phase capacitor is charging, and then transistor become active and capacitor is discharging. Can we see this anomaly? Now capacitor is discharging, IB is decreasing. When capacitor is discharging, IE is decreasing. When capacitor is discharging, IC is decreasing. While capacitor is discharging, VB is not decreasing. Okay? It is at 0.62, 0.61 and 0.6. So it is like a flat. Capacitor is discharging all the while, but BB is not discharging. This is the internal energy of the transistor circuit. And when it feels that it is completely gone, then it is behaving like a switch. And then voltage completely drops. Okay. Then VB is charging, like when capacitor is charging, and then suddenly it comes up. Okay. When VB reaches 0.44 volt, 4.4 volt, as per its internal nature, it picks up to the active region. So this is something very interesting that should be seen. Okay, so we saw the I base. So transistor become active, and then I base started losing the current, and as per the capacitor it discharging, and then it becoming. Now we'll see the most important, the voltage across the capacitor. So voltage across the capacitor is first we see that it is at high level voltage, and then voltage drops. Okay, where transistor become active. So from this region to this region, transistor is active. When transistor is active, capacitor is discharging. Okay, now transistor is inactive, so it is finding a full path from the VCC to charge again, and this much it is charging capacitor. It reaches to a level when transistor become active and it is discharging. Now if we see the time instance, when it is when it starts the discharging and when it starts the charging. Okay, so Okay, we have measured the voltage across the speaker also, that we can see that it is reaching 1.3 volt. But anyways, now if we see the calculation of the capacitor, the voltage across the capacitor is at any moment it is Vs1 minus e to the power t by Cr. So if I go ahead, then time it takes to charge the capacitor is minus Cr ln 1 minus Vt by Vs. Okay, we use Python code. So now 75.75 is the capacitor. I have taken full 330 kilo ohm and 10 kilo ohm while charging, and then if I do the computation, it comes around 25.33 seconds. So that much it should take. Okay, so that much kind of it should take. Okay, I mean, I think it should be opposite. Okay, so this is experimental, what we saw, and this is theory. So with theory it should take around 25.33 seconds to charge, but generally it takes around 29 seconds. So I believe it's okay. 10% error in capacitor and resistance value, I believe it's okay. While discharging, we cannot, experimentally it takes around 5.2 seconds, but we cannot go with the conclusion, because if you see the capacitor voltage, okay, so capacitor voltage, it is not showing here, but it reaches minus. So capacitor voltage reaches minus means, okay, capacitor, not capacitor current, capacitor voltage reaches minus. This proves that if capacitor is discharging, okay, and while discharging capacitor is reaching minus, this proves that there is still some voltage level here. Voltage level here means IC is there. So transistor has not gone kind of completely switched off, and there is a current in IC, so voltage drop is there. If voltage drop is there and there is no voltage coming from this side disconnect, capacitor would start charging from opposite side. So that is the problem. It has no practical polarity. So that's why if we see the capacitor voltage, then it is reaching in the minus side. So if there are voltage and those kind of things, so I think it's okay. It means we should omit this. We should leave this capacitor discharging time. Okay, so this is how it is. So we saw that capacitor charges from VCC, and when it comes to a level, then transistor become active. As soon as transistor become active, this path is over because this has low resistance, and capacitor starts discharging while transistor is active. So active and discharging both are happening at the same time. Okay, now when both are happening at the same time, transistor become active, but it is losing the current, IE, IC of the PNP all. Okay, and at that time capacitor, when transistor is active, capacitor is flowing in negative direction, current means it is other way, then it is charging, and I base is also losing the current, IE, IC, I base all are losing the current because capacitor is discharging, but VB is not losing. It is standing at one location and it is completely going down instantly, it behaving like a switch. Okay, and then capacitor kind of at the time it is discharging. When capacitor is discharged completely, transistor becomes switched off. When transistor becomes switched off, so this path to the right side, it is kind of infinite resistance, and capacitor starts charging again. So this keeps happening. So when we see kind of the sound on the speaker, because voltage current here is reversing. So if we see the voltage level at the speaker, so voltage level at the speaker, if there is a sharp change in the voltage of current, then it will make a tick. If there is a sharp change, there is no sharp change. If there is a sharp change here, it will make a tick. Then, okay, then there is a sharp change here, it will make a tick. So, wherever it feels the sharp change, it will make a tick. So, when transistor is becoming active, it make a tick, and when transistor is becoming inactive, it makes a tick. So, that is the kind of a story of the speaker. Okay, we can kind of go with Audacity also to see actually the waveforms. It will take some time to kind of load it. Okay, so it is almost done. So we can see the spikes when it oscillates. Okay, so if I kind of, can we see this? So when it oscillates, there is a spike. Okay, so it is oscillating, it is making noise. So there are spikes that we can see. So this spike confirms that it is oscillating. See, we can see the spikes. So these are the spikes that we get in Audacity when it makes. So it is a kind of sharp noise it makes at that time.